7:02. The Naked Scientist.
It's 24 minutes to 3 o'clock, one of my favorite times of the week, because you never know what you're going to get. As Forrest Gump says in that film, life is like a box of chocolates because you never know what you're going to get. Well, guess what? This time with the Naked Scientist, it's just like that. Good afternoon, Chris. How are you?
Makes two of us, doesn't it? Neither of us know what the other's gonna serve up. No, I'm good. How are you?
I'm well, but the pressure's all on you because you've got to serve up something good with your answers.
I never failed to do that, surely.
No, you never. And I think that's what we marvel at every single week. We already have your calls lined up, Chris. Quite a few of our listeners ready to pose their questions to you. Mtunzi is first up, calling us all the way from Margate in KZN. Hello, Mtunzi.
Hi, Azang, and hi, Dr. Smith.
Hello.
Yeah, my question is very simple. I guess the answer is rather complicated.
Okay.
It's a simple matter of this. We have theories on all kinds of theories on how to travel faster than the speed of light. Of course, we don't really have the math right or whatever, but I was just wondering, how would we manage to actually see faster? In other words, every time we see something that is light years away, we are seeing it in its path, so to speak. So how would we first be able to see faster before we even know how to actually get there? So how would we solve that problem first, and are there any theories around that?
Well, the things which we look at when we're seeing something in the way you're describing, and you're quite right, if we look deep into space, we can see light which is coming to us from across the vastness of the universe, and that light has been travelling in some cases for billions of years. We can see back almost to the start of the universe, not quite to the beginning for various reasons, but we can see back billions of years. And the reason we can see back in time in that way is because light has this speed limit. It doesn't go more than 300,000 kilometres per second. And so there's therefore a speed limit on how fast the light can travel through space towards us, and it takes time for light from very distant parts of the universe to reach us. Therefore, that time delay corresponds to the distance between us and that far object, and it's perfectly conceivable that you're looking at light corresponding to something that no longer exists where that light came from, because the light's taken so long to get to us. So if we're making observations using light, then the observations we make can only be made at the rate at which light reaches us. So if you watch something, the light from that object that you're watching is going to come to you at the speed of light, and you can't do anything about that. And therefore, it's a tricky one to solve, because if you're going to use any kind of measuring device, whether that's light we can see, light we can't see, like radio waves or even X-rays, or even gravitational waves, they all travel at the speed of light for various reasons, and therefore you're constrained by how you're going to measure something moving. But it's for those reasons that we believe that because of the rules of physics, that you can't go faster than the speed of light. And the simplest way of explaining this is E equals mc squared. E is energy, m is mass, and c is the speed of light. And if you increase c, the speed of c goes up. That means the energy goes up, and if the energy goes up, the mass must go up. So as you go faster, you get heavier. If you get heavier, you need more energy. So you need an infinite amount of energy to make yourself go faster and faster and faster, until in the end you can't go any faster because you need infinite energy, and that's the speed limit. So this is why we believe that you can't actually break the speed of light as a speed limit. But what you might be able to do is to find ways to shortcut the process, and that's why people talk about the concept of a wormhole, where you take bits of space and you warp space and bend one bit of space to meet another bit of space, and that means that you make the distance that you're travelling relatively shorter, so it gives the impression you're going faster than light, but what you've done is to take a shortcut, so it takes less time to get there.
Yeah. Is there time for a follow-up question?
Yeah, go ahead quickly. That? Yeah, go ahead.
Okay, cool. So we took a photo of a black hole last year using some very complicated means. Is there a means then of peeking through that? I mean, obviously that's now interstellar space, but is there a means of I don't know, ever peeking through that? And is it a case of when we discover how to travel there, or let's say use wormholes or whatever it is, that we'll probably simultaneously discover how to see things faster, or however? Or how would it work?
When you say we took a picture of a black hole, this was very striking, wasn't it? The image that was circulated last year, but that wasn't actually the black hole. What you were seeing was the absence of light coming from a patch of space which corresponds to where the event horizon of the black hole is. The event horizon being the point of no return. The black hole is a warping of space to such an extent that not even a light wave can get out of it, which is why it looks black, because it's not giving out light from beyond that event horizon, so it looks black. So with our present ways of measuring things, given that we're looking at light and we're looking at gravitational waves, the light can't get out, but gravitational waves are one product of massive objects doing things in space because they warp the fabric of space. And that's why the discovery of gravitational waves and the fact that we can measure them is so important, because it gives us a new regime with which to interrogate massive objects like black holes, and black holes engulfing other objects, interacting with other objects, because written into those gravitational waves is subtle information about the thing that made them. And that's how we can learn in a new way about some of these distant entities that previously have been very difficult to study.
Fantastic.
Mtunzi, thank you for getting us started. And I think maybe you carry on the conversation with the Naked Scientist on the handle. It's at Naked Scientists, plural, on Twitter, if more questions arise.
Thank you very much, guys.
Thank you. That's Mtunzi in Margate. Alistair, thanks for your time as well. You've got a question for Chris.
Hi, Azania and Dr. Chris. Two-part sensory question. Tears. We create them to clear and clean our eyes, but why do we cry? As they have no reason to form. It's like at a funeral or watching a movie, you know, or even when Liverpool win the league every 30 years.
or if you're not a Liverpool fan, when Liverpool win the league.
Man United.
Yeah, Man United. Quite well. The reason for tears, okay, they're a very visible manifestation of emotion. And humans are very visual species. More than a third of our brain substance is devoted to just what goes in through our eyes. We devote a huge amount of neurological processing to vision. And the equivalent, if you look at a dog's brain, a third of a dog's brain is devoted to smell. We are the visual equivalent. So we put enormous precedence on vision. We have enormous amounts of neurological territory devoted to decoding vision, and therefore we have evolved, because we're a social species, at giving information visually. When we're angry, we become very red in the face. We puff ourselves up, tense all our muscles, and snarl at each other. We also, when we're very happy, smile. We change the colour of our skin in subtle ways to give away these emotions. We also cry. And tears can signal an extreme of emotion. So it's almost like your body, your vision, reads the facial affect of a person and says, right, okay, I think I know what mood they're in. And then tears add a bit more on top to say, I'm in this much of a mood, and this is the evidence for it. So it's another non-verbal cue to what we're trying to communicate to each other and the extreme to which our emotions are running at the time. And it's just because we're such a visual and social species that we do that.
That's a brilliant answer. Okay, so then the second part of the sensory question, can you hear me?
Yes, go ahead, Alistair.
Is it only me, but when I watch scenes from a movie of heights, like on the edge of a ledge, or those guys climbing cliff faces without safety lines, the soles of my feet start to tingle like a nerve feeling. Does that happen to everyone?
I know what you mean, and the reason that happens to humans is because we have a population of nerve cells in our brains called mirror neurons, and the reason we are so successful socially is because we have the ability cognitively to put ourselves in other people's shoes. In other words, when you see something happening to somebody else, you take their experience, you map it onto your own brain, and you almost recreate the mental image of them in your head, which enables you to then experience how you would feel if you were in their position. Right. And different people respond to that in different ways. I mean, it sounds a bit crude, but there was someone, I won't say her name, but she used to work for Eyewitness News. And she told me that when she gets certain emotions, that she gets a funny feeling in a private part of her body. And we were all laughing about it, but I said, no, I've got this funny thing where actually if I pinch the side of my body roughly to the side of my sort of thorax, my trunk, on the sides. If I pinch there, I feel that in my elbows, and it's a cross wiring in the nervous system that does that in that case. But I think in your case, basically, when you mirror the experience, anticipated emotions of those other people, your nervous reflex, your nerve reaction being mapped onto your nervous system is that sensation. And we all have these sorts of sensations because of our ability to put ourselves in a third party's shoes.
Alistair,
Well,
lovely questions.
That sounds like a Reedy Clarby sensation.
It wasn't Reedy. No, it definitely wasn't Reedy. I promise it wasn't Reedy.
DWA.
Reedy would have told me, I'm sure, because Reedy was very honest like that. No, this was somebody else who is actually a news editor. Put it that way.
Oh my goodness, Chris.
Secret stay with me. Bye.
Go away,
Bye,
Alistair.
bye.
Go away. Let's take a break on that note.
702. The Naked Scientist.
It's 11 minutes to 3 o'clock. Gosh, we've got quite a few to get through. So let's go straight back to the lines. Roy, hello.
Hi, Zanya.
Hi, Roy.
Dr. Chris. How are you guys?
We're good, thanks. What's on your mind this afternoon?
So I'm wanting to find out how much further away is Mars from the sun than the Earth?
Okay.
Hi, Roy. It's 9 months if you're going on a space probe. I need to look up the exact distance because I don't know that, I'm afraid. But yes, the shortest distance to Mars, if we take off when Earth and Mars are in the same parts of the solar system, because remember, they're going on a big orbit around the sun, but they're not going around at the same time as each other. So Earth is moving at a slightly different rate to Mars. So at some points, they're very close, and other points, they're on the opposite side of the sun from each other. So the distances between the two planets are going to vary enormously. But if we arrange a time when the Earth and Mars are at their closest, and you launch your space probe to Mars, it takes about 9 months of spacefaring to get to Mars. I'll tell you what I'll do. I'll find out next week what the actual physical distances are at those different points for you.
All right, Roy, there you go. Make sure you listen next week for the answer.
Okay.
Thank you. And then let's go to Jim in Randburg. Jim?
Yes,
Hi.
Hi. My question, Tommy, Chris, as a scientist, do you believe there's sufficient rational evidence for South Africa's ban on cigarettes during these COVID times? Because actually, surely the amazing truth is that smokers are statistically doing better.
That you sound like a very frustrated person who's not been allowed to have their cigarette ration, and I am sorry if you're in that situation. Look, the situation is this: that South Africa did put in place this ban on cigarettes, and it's certainly true that people who have a bad chest to start with are at high risk of having a bad outcome with coronavirus, and smoking can cause a bad chest. Smoking also means that you don't live as long. So the people who are most at risk from COVID-19 are the elderly. And one cynic said to me that smokers don't live long enough to be sufficiently old to get bad coronavirus infection, and that's why they're getting away with it, because they've already died of other things. I mean, that there might be a grain of truth in that. It sounds flippant, but there may be a grain of truth in that. Where the whole kind of business comes into, it gets interesting. France actually reported an apparent association between use of nicotine replacement therapies like patches and sprays and so on, and a reduction in infection rates. And there's a suggestion that nicotine might reduce the expression on certain cells and tissues of the receptor that the virus uses to get in to those cells. It might be that that's the case. On the other hand, smoking increases the amount of the expression of that receptor. So it might be that there's a balancing act going on between smoking making it more likely you'll get infected and nicotine making it less likely you'll get infected, and some people are sort of doing a bit better, some a bit worse. But this is very preliminary. I haven't seen proper peer-reviewed published evidence about that. At the moment, I think actually, I mean, I'm a doctor, I'm a non-smoker, so, you know, I'm biased, and I do feel for people who are smokers and now feel that their rights are being eroded. You know, if people want to smoke, as far as I'm concerned, that is up to them. But I do think this is an opportunity for people to try to kick the habit. And sometimes something like this can help them, because 75% of smokers say they want to quit. And most of them have tried many times and failed because it's incredibly hard to do. Although Mark Twain once said, giving up smoking's easy. I've done it hundreds of times.
Yeah, Jim, there you go. Thank you for that one. As this issue continues to rage in South Africa with no clear end, petitions, and just saw a tweet from someone wanting to bombard a comment or opinion line that asked a question about smoking. And so that frustration certainly being felt by South African smokers. Let's go to Steve in Eden Vale. Hello, Steve.
Hi, I just wanted to find out, all over the world these days, you find these huge electrical wind farms with the big turbine fans.
Yeah.
And they're spread all over a large area. Why don't they bring them all together closer and save a lot of ground?
Yeah, hi Steve. There is a good reason for this, and this is that there is an optimum separation for them in terms of both how you erect them, how you maintain them, so you've got safe distances so you can get to them and maintain them, and also because of modelling the airflow around them, because the turbine is extracting energy from the passing air, and therefore it will create an energy shadow behind itself. And if you put a bunch of turbines right in line, one behind the other, the one at the front will see all the wind and extract loads of energy from it, the one behind less and so on. And so the efficiency would drop away. So you have to position them optimally to engage with the most wind, to mean that they can therefore make their energy the most effectively, use the least footprint, the least destructively that they can, and be sufficiently spaced so they're safe to maintain and control. So those are all the factors that play a part. The good thing about wind turbines is that they have very little environmental impact apart from the noise pollution that they make, because when you take them away, there's just the platform, which is a concrete base that they were bolted to as their foundation. Nothing else, no other impact. Very easy to remove everything. It's not like a nuclear power station that's going to be there for 100,000 years, or a coal-fired power station that will put CO2 into the atmosphere that will be there for thousands of years.
So I'd rather have that, in fact, that hum and that the sound that they make, rather than one of the others, as you've just described there. So interesting question, Steve. Love it. Thank you for.
Thanks.
Thank you. He's calling from Eden Vale. Let's go to Fourways next. It's Akani. That's where we find you today. Hi.
Hi, Azza, and to you also, Dr. Chris. So I have a dilemma. My dad has been discharged after spending time at hospital for 3 weeks with COVID, and we thank God that he's out of it. But to my surprise right now, I just asked my daughter to, call the hospital to find out what are the risks and, day off, and how we should go about it, as we are taking him back home.
Yeah.
And if at all he has tested negative. So the nurse, obviously the doctor didn't speak to us. We understand that they might be overwhelmed about the whole thing. Obviously many people are getting admitted, so he's not able to communicate or to talk to us. But my daughter just found out that, he is still positive. And so we don't know. As much as we're happy that he's coming back,
how much of a risk is it? Okay.
What are the risks? How powerful is it? It's been 3 weeks.
Yeah.
Is it,
Yeah, no, it's an interesting question you raised, Sakani, because even I think about 2 weeks ago or 3 weeks ago, there was that issue that if your symptoms are over and you're feeling that your health is improved, you can even return to work, for instance, and employees have had to make their own decisions around that. Do you wait for employees to test negative, or is it about health returning even though the person is still testing positive? So, Chris, what is the understanding there? How much of a risk does the father pose? Do we have to wait for a negative test?
Sugani, you've actually hit the nail on the head with one of the most pertinent questions we're all asking at the moment. The tests that we're using to diagnose coronavirus infection are excruciatingly sensitive. They will detect as few as 8 copies of the virus genetic information in a sample. And what they can't discriminate or distinguish between is virus that's viable and capable of causing disease in another person, and pieces or shrapnel, fragments of the virus left over after the immune system has demolished it. And what we realise is that although we can continue to test people positive for an extended period of time in some cases, they're probably not infectious. You're at your peak of infection just before you get symptoms, and probably for about a week after you become ill. And then because of the immune response, the amount of virus that's viable in your body plummets. And if you have very low levels of virus, you're not going to pass that on to anybody. So you're not going to be a risk to anybody. But because the tests are so sensitive, it's very likely they're going to continue to find traces of the virus for quite some time. We're actually doing an experiment at Cambridge University at the moment where we've got samples taken from people who've had coronavirus infection, and we've tested them at various time points afterwards to gather virus, and we're going to do an experiment to see if the virus is viable. In other words, if it can infect cells in a dish, proving that those people have viable virus or not at various points. And we're setting that up at the moment, but it's an open question at the moment. We don't know the answer, and it's a very good question, but you should be reassured if he's recovered. A, I'm delighted to hear he's better, and congratulations, welcome home. B, the likelihood of him actually being a threat to any of you lot now is extremely remote.
Okay.
Oh,
Thank you, Tsakani. Thank you for raising that very important question. We're out of time. And someone reminding me, Quincy, saying, don't forget your question around whether we can smell in space. I've got to take ads and the headlines. A quick yes or no, and then we'll elaborate next Monday, Chris.
Well, it depends. If you're in the space station, of course you can smell because that's an atmosphere. But if you're in space, space is nearly a vacuum. So no, you can't.
There we go. Thank you for the reminder, Quincy. As always, wonderful session with you, Chris. Looking forward to next Monday.
Thanks, Hazza. See you soon, everyone. Bye-bye.